So we've been talking about how to solve a system of equations by first putting it in triangular form, where you've got 3 variables, 2 variables, and 1 variable. That's assuming you have a 3 by 3 system. And we said in order to get it in that form, you do these 3 row operations as come up with by Gauss. You can exchange two equations, any 2 equations, switch the order. You can multiply one equation by any number that you want as long as it's not 0, and then you can just do some linear combination of those to replace one of the equations. Add 2 times 1 and then add that to the second one, and that replaces the previous equation. So let's take a look at an example. So here's this system of equations. I'm just going to go ahead and label them with an A, a B, and a C. And the first thing that I want to do is notice that the top equation's fine. I have a 1x in front of it, and I don't have to worry about the y and the z here. But on the second equation, B, I need to get rid of this x. So that's the first step, is that you have to get rid of the x's in the bottom 2 equations. Keep the 1 in the first equation. So you ask yourself, what can you do by adding, multiplying, or subtracting these equations to get rid of this term? So the obvious thing is that I can just add a to b, and that will get rid of this term, because x minus that x, they disappear. Now, whenever I do this, the top equation is going to stay exactly the same, and the bottom equation is going to stay exactly the same. The only thing that's going to change is my equation b. So what I'm going to do is I'm going to add a to b. Equation a stays the same. Equation c stays the same. In my new equation for b, the x's will cancel out. Negative 2y plus the 3y makes 1y. 2z plus nothing equals 2z. And add up 9 and negative 4, get 5. So there's my new system of equations. The next thing is I have to get rid of this 2x. So I can't combine it with the middle one because it doesn't have any x's. So I'm going to combine it with the top equation, and it needs to have the opposite coefficient, so it's got to be a negative 2a plus c. So my tip here is that I would actually take this original equation and just multiply everything by negative 2, so it's easy for me to line up and add my equations. So there we go. So just remember, the original equation A is going to stand. This equation for B is going to stand. The only thing that's going to change is C. So its new equation is going to be 0, 1y, negative z, and 2. Negative 2. Okay. So now I got rid of those x's. The next thing that I need to get rid of is this y. So then it would have that triangular form. So to get rid of that y, I don't use the top equation with it, because if I did, I'd add up the 2 equations and then I'd get this x term back, which I don't want. So I can only use the equation that was right up above it. And the obvious thing to do is just to add up equation b with equation c. So whenever I add equation b to c, the top equation is not going to change. The second equation is not going to change. I would just get 0 for the y's. 1z is equal to 3. And now I've got my system in triangular form. It makes that little triangle. And in order to solve it, I would just take that 3, stick it back in there for z, get y, find both the z and the y and plug it into the top equation, and then it's done.